Okay, I look at this thing. Well, absolute value is going to have to be done first, because that's like a set of parentheses. That's a grouping symbol. And we know this is a minus, which is turning into a plus. So this will be 17, subtract the absolute value of 5 plus 2, which is 7, add 12 divided by 2 times 3. And you might say, well, why didn't I do something? Because I've got that stupid, if this were another addition, I probably would have gone ahead and multiplied 2 times 3. But I've got a division there, so I've just got to kind of keep these things separate. This is a subtraction. This is an addition. This is a division. This is a multiplication. So I'm going to have to do the division, and then I can do the absolute value, because those are separate terms. So 17 subtract, absolute value of 7 is just 7, add, division is 12 divided 2 is 6 times 3. Now I have a subtraction, an addition, multiplication. Multiplication gets done next. So 17 subtract 7, add, 6 times 3 is 18. And now I can go from left to right. 17 minus 7 is 10, plus 18, and we have 28. Here's the good news. As you move forward in mathematics, things get complicated, but they don't usually look this ugly. They just do this to torture you. Yeah?
So do parentheses come before absolute value or afterwards?
They will have the same level as absolute value.
So you're finding the absolute value of the numbers in between the two options?
Well, essentially, what always happens is you're going to have to, if there's something inside absolute values, like if these were parentheses, you would do what's in the parentheses first. So in this case, you have to do what's inside the absolute values first.
So technically, it wouldn't be like 5 minus parentheses 2, that's positive 2 first? And then
Yeah,
we
which
go
is what we
after that.
did, yeah.
Okay, and just go after that.
No, well, actually, this is going to be take the opposite of a negative 2, which is a positive 2. So your minus and a minus becomes a plus. And that's where you're going to get the 7 from. So when you're looking at absolute value, it's included in the grouping symbols. So you got to do what's on the inside first, if there's something inside. Then I look at this and say, what else do they want me to do? One thing I have to do is I have to do what's under here first, because square root acts as a grouping symbol. And then I have the squared thing. So that also has to get done. So 24 divided by the square root of 3 times, well, 5 minus 2, I have to do what's inside the parentheses, is 3, divided by that thing squared. And this is 1 minus a minus 3. Minus and a minus is a plus. So it's going to be 1 plus 3. Negative 1 plus 3 is positive 2. And now I'm still working with these dang symbols. So 24 divide. 3 times 3 is 9. Square root of 9. Divide. 2 squared is 4. 24 divide 3 divide 4. So I got divide. I work from left to right. So I divide that one first. That gives me an 8. Divide 4. And then 8 divided by 4 is 2. This one I'd probably pull my calculator out and do it on it. Except for one thing. Is that radical? If you're going to do this kind of thing in your calculator, This whole thing is under the radical. And once you go to do square root on your calculator, square root is above x squared. So I'd have to do second x squared, there's square root. Notice it has a parenthesis. What is there, it doesn't draw a bar across it. The parenthesis says what's under starts here, and then you end it with a parenthesis that says everything that's in the parentheses are under the square root. So I have to be very careful how I'm going to put that in there. So this would be square root parenthesis 3 times, then I put in exactly what I see. But this parenthesis goes with the 5 minus 2. That means I have to have another parenthesis to close off square root. If I don't do that, then it assumes everything then I type in afterwards is still under the square root. And when I was writing computer programs, calculators are rather forgiving most of the time. It wouldn't be forgiving on this problem because it's got stuff after the square root. But I always have to count parentheses. I have to have as many on the left as I do on the right. So I notice I have 2 lefts, and if I stop there, I'd only have 1 on the right. But to finish off the radical, I have to have a parenthesis, so that would be 2 on the right. Because this is what's under the radical. Beginning of the radical, end of the radical. So if you're going to use your calculator to do some of this stuff, you got to be very, 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 very careful. And like I said, if this weren't there, it wouldn't matter if I had that second, whether I had this parenthesis or not. If that parenthesis is not there, it'll drag that whole stuff in underneath. I said, oh, I'm not done. It goes all the way to the, it looks for that second parenthesis. The beauty of computer programming. Distributive property. Distributive property says that A times B plus C is AB times AC. It's like A, B pollinating a flower. A times B, here's your center sign. B times C, I'm multiplying by a positive A. If I'm multiplying by a negative, it would change the sign in the middle. So this then becomes 5 times 4x added to 5 times 7 to remove parentheses. When I look at this guy, this is the same as a negative 1. So this would be a negative 1 times 6x subtract a negative 1 times 3. That's what it's actually doing. Or negative 6x minus and a minus form a plus 3. When it says simplify each algebraic expression, what it means to do is to combine like terms, remove parentheses and combine like terms. So that x squareds are different than x's. So here is a 9x and there is a plus 3x. So that's going to give me a 12x because 9x is plus 3x is 12x. I'm counting how many x's I have. Here's an x squared. I have 3x squared plus 4x squared is 9x squared. And I can't bring these two together because one's an x squared and one is not. Think about a complete sentence. Using the distributive property, and remember this is going to be a plus 1, so it's going to change all the signs in between. So 4 times 5, that's 20y. Subtract 4 times 3, that's 12. Minus 1 times 6 is minus 6y. Minus 1 times plus 3 is minus 3. So it's a pollinator. Now you combine like terms. I have a 20y and a minus 6y is how many y's? 14 y's. And then I have a minus 12 and a minus 3 is how many? Minus 15. And I've got to do this first. That's your grouping symbols, order of operations. So I have a 14x squared plus 5 minus square bracket 7 times x squared is 7x squared. 7 times minus 2 is minus 14 plus 4 square bracket. Continue to do what's inside the brackets. Plus 5, subtract. I don't have any x squareds, but I have a minus 14 and a plus 4, minus 10. Now remember, this is a minus 1, so it's going to change all the signs on the inside. I'm going to move this to the side. So 14 x squared plus 5 minus 1 times plus 7 is a minus 7x squared. Minus 1 times a minus 10 is a plus 10. So 14x squared minus 7x squared is 7x squared. Plus 5 plus 10 is plus 15.